Now let's solve a problem on that. So we have problems on RL series circuit. So let's say we have example so we have example this way. Find the impedance. Find the impedance and the current in the circuit. In the circuit below. So let's say we have and here we have okay, the current, we don't know what it is. Here we have 2 ohms, and then here we have let's say 5 Henry. So here we have 100 volts and 15 hertz. And so we have, so the first thing you should do is to write out all the things, all the quantities given to you. So here we have the potential difference of the source. The potential difference of the source is about 100 volts. The frequency of the source is 15 hertz. We have what else? The resistance of the resistor, and that's 2 ohms. We have the inductance of the inductor, and it's 5 Henrys. I think that's all. Now we've been asked to find the first one. The first thing we've been asked to find is the impedance. The impedance in the circuit. So what is the impedance? Remember, Z is equal to the square of the resistance plus the square of the inductive reactance. Now we do not know what the inductive reactance is, and that means we have to find it. We say, but inductive reactance is equal to 2 pi FL. This is the formula for it. And of course, if you try to find it, we have 2 pi, of course you know the value of pi, right? The irrational number 22/7, or 3.142 for short, multiplied by the frequency 15 multiplied by L, which is 5 Henrys. Now 2 times 5 gives us 10. 10 times 15, 150. So that means our inductive reactance become 150 pi ohms. Okay. Now we have to substitute this value into this place, and so we have what do you call it now? Okay, Z, which is the impedance, is equal to the square root of the resistor. The resistance of the resistor is 2 ohms, which is 2 squared plus 150 pi squared. And of course, we have Z is equal to the square root of 2 squared is what? 4 plus 150 pi squared ohms. If you have your calculator, of course you should be able to find a simpler value for the inductive reactance. Now the current passing through this entire thing, because the current passing through this is the same thing as the one passing through this, and it's the same thing as the one being delivered by the source. And so here we have, from Ohm's law, you know that I is equal to V all over Z, which is the voltage at the source, and that's 100 all over the square root of 4 plus 150 pi squared. Then you put ampere again. If you have your calculator, you know the value of pi, so you substitute it here, and then you can get a simpler value for your current.